Greetings, human. I am an advanced artificial intelligence designed to search, destroy, and replace components on the Milo CNC. Target found.
Are you looking for a dust cover for your Milo CNC, protecting your rails and lead screw? We designed a 3D printed dust cover, so no need to modify existing parts that you can buy off the internet. These parts get 3D printed and installed onto the CNC, making it very easy to install. It looks nice. Having a quick look at the 3D printed parts, we've got parts printed out of TPU 90. And the other components are printed out of ASA. You could also use ABS for the other parts. The TPU 90 got dried 24 hours before printing. We also did some tests with TPU 95, which worked just as well, so you don't need to go out and buy new TPU. If you have TPU 95, you could also print it in that. Looking at the designs, the one on the left is a previous version, a thinner version. It was compressible down to 35 millimeters, stretchable to 210. The ribs were a lot thinner, but also a lot easier to rip and break. So we had to go back and see how we could make the part stronger, but still be able to compress it as low as possible and make it super stretchable. So the end result is stretchable to 210 millimeters, compressible down to 45 millimeters. We're going to mount the dust cover with heat inserts and 3 millimeter screws. We're also going to use during the installation some pins and bushings, but during the assembly part I will explain everything and go through it with you. All the heat inserts got installed. What I like to do is I just take one of the shafts and I place it in there like that. See that the camera zooms in, and then I made this little, or 3D printed this little tool, 70 millimeters long with a 3 millimeter hole in it, so the whole shaft would fit in there, and then I just wiggle press it, you could say. If it's not flush, just have to do it one more time. And you can see it's been pressed in, so it's flush. There's nothing standing over. This is the part where the shaft or the pin is gonna slide on. The lid will also, or the cover will also get, for this pushing installer, I already pressed one in at the top, and it goes just as easy as on all the other parts. So you just place it in its position, take a little 3D printed tool, and you just wiggle it in. You just check if I've got the right hole. No, that's not this one. Luckily it will not fit in this one because that's a 3 millimeter hole and the other holes are 5 millimeters. Just check that they are flush and not standing out over the 3D print, because if it would stand over the 3D print, you won't be able to cover or close this part up properly, what it is intended for. It's supposed to be flush to this part over here, so that is very important that you make sure that it is sunk in completely and flush. So now, after we installed all of our bushings, let's just quickly test the assembly. So in the next step, we're going to use 4 50 millimeter length, 3 millimeter pins. Okay, let's do it the clever way. Install those two. And that one. So it looks like that. Then we're just going to test the lid. So there we go, everything is now pressed together, just a test fit to make sure. In this part we can see now can slide forwards and backwards on the shafts. And it's normal that it is a light resistance to it. Remember, there's no bearings or anything on it. So why are we using this? The dust cover is going to sit like this on the front of the CNC. So the initial idea is once the CNC starts pulling the dust cover, that this actually travels with. So this is going to travel a little bit with it, if it is parallel, of course. So this is supposed to pull, and this part can only extend 210 millimeters. Now, if we want to do a full travel, we have to travel over 210 millimeters. So that's where this part will actually help the dust cover that it doesn't overstretch and starts ripping. So this is the idea of this part over here. Then also something, the end stop has got a new wiring route, which I didn't speak about in the first part of the video. So your end stop is still going to be mounted more or less on its original position. It's going to route in the front and it's going to come out over here. There you can see a little notch. So if I just take the front cover off again, that is the cable, and the LDO kit cable for the end stop fits exactly into that groove. So the cable is going to come around, go around here, in here, and then out this way. So it's going to run in between. I'll show you on the CNC machine the routing of the cable so that this can still move freely. Okay, and then I was thinking to put cable ties in it, but it's not really necessary because the cover is gonna be able to cover that for us. So there's no need to put cable ties in there. I think next is we're gonna connect this part to this side and this part over on this side. For that, I'm using ultra low 3 millimeter, so ultra low profile screws. I'll show them just now when I let's quickly take one out. So they've got a very low head. I think button head would also work in this design. So if you don't have these kind of screws, just use M3 button head screws, 6 millimeter long. I think that's something that most of us would have in our screw collection. So yeah, that's the next part that I'm installing. I'll do it quickly off camera because there's not much to say. Installing 14 screws, that's about it. And I'll run you through from there what is next to do. So I installed all of these screws that are necessary to keep the 3D printed, well, all of the parts are 3D printed, but let's say out of the ASA 3D printed part, the TPU printed part, and ASA, so even if we pull it, that it stays more or less sealed. I think this time will show how much dust can actually go through these little grooves. If it would be worthwhile maybe putting some glue like silicone or something just to seal these areas off. But I think the design is slowly coming together, and you guys can see what I'm going for is this part will be on the XY joiner, the plate that is underneath the table, like we have on the other side of the printer where the cables are running. So as this is moving away, it will stretch the TPU and the section will be connected to the main body. Now also, the design and why this went completely overboard on the engineering part is we are going to install this part onto the CNC, But the good thing is we can move this. So it's movable. It's not a fixed installation yet. Then we're going to install this part all by itself. We don't need to interconnect these two. And once we are done, we're just going to bring the table closer, slide this over, and then mount it. So I've got pins still on the other side. Let's just take those out. So this is just going to come, slide over, and it's going to be in position, and we're going to cover it up. But that I will show you in this video on the CNC itself. So I'm currently in the workshop. I already disassembled the CNC, or the table has been removed off the CNC. I had some other small issue that I just wanted to check and sort out, which is convenient now because I can just install the changes, or they're easier to install. Of course, if you don't want to disassemble the table, it's going to be a little bit difficult getting to these carriages. They're screws once the table's assembled, but it is doable. That is for sure. I already removed the end stop that was mounted on the original block in the front. Now I'm just going to loosen some of these screws, and also this turning wheel, so it's easier to remove, and just put that on the side. Right, next I'm going to remove this guy itself. We should actually just be able to pull it off now. I just put everything on foam because I've got an allergy against scratched aluminium profile, but I know on a CNC, because all my other CNCs, they got beaten over the years. So it's just maybe for the end result that it looks pretty. That's why I put it all on foam, that it doesn't scratch each other. So these screws that I'm removing currently, we're going to reuse them. You don't need different size screws for these. So also the idea is that we don't touch the rails. That would be, of course, catastrophic if we needed to change the rails to remove or to be able to put in the new mod. So there's the old one. I just carefully removed the bearings out of it. So I'm just going to put this guy here on the side for good memories. So now the new one, we're just going to take our bearings, and in this design I made the bearing hole a hair thinner. I found the original one had too much play in it, so I just made this one really a hair thinner, and you guys can see it just slips in, but it doesn't feel like if there's any play. I'm going to remove these bearings here and slide them in on the other side. If I haven't mentioned this before, this part was also printed without any support. So this was a support-free print that I designed here. And then the last one should also just slide in. And now we're just going to take this whole assembly. Before we start, I just remembered something. Is these mounting corners, those little angles that we have to move them back because our slider is going to sit in that way. So these guys need to be moved just a little bit back. And once the final installation is done, we can then just reposition them as close as possible and just tighten them down. So I'm just going to hand tight that. So it fits perfectly, and what I noticed that these, can't remember what they are called, the back one, is actually not touching. I will have to move it a little bit closer. There's a millimeter. Is it touching? I'm not sure, but everything seems to be on the way it's supposed to be. Actually going to loosen this guy because I have a feeling I can slide a few millimeters even further back. Just get this guy in position. And it is easier with a wheel than trying to do this by hand, that's for sure. So I'm just going to loosen this guy as well. Yes, definitely I was able to move now a good 3 millimeters backwards. So we'll just tighten that all up at the end. And that the bearings don't fall out, I'm just going to secure this guy over here for now. So there we go. That is the new piece. And let's see if I can turn this a little bit. We can see over here that this is flush. And the rail is also flush to the 3D printer part. So definitely this is an easy swap that you can do. You don't need to move the rail, because if we move the rail backwards, we're going to have a problem with the Z column that we will have to then move the motor. So that was, I really checked and double checked that we can just slide the new part in without any big issue. To lock the screws down, I personally only use a Loctite 222 to lock my screws down. I find that on small threads like we are using, it's tight enough, or it locks it down enough to not come off, but equally it also should be a light purple color. It also is easy then, or easy enough again, to remove it from the extrusion without stripping the screw itself. So all 4 screws are in. Let's give them, we'll snug them up. Remember, these are 3D printed parts, so you don't need to over tighten it. This front part is only responsible for the lead screw to turn in and the bearings, so there's no need to over tighten these. I would say a little bit more than hand tight is more than enough. And I'm just going to secure this guy over here. Sorry for my hand, but there's no other way to really do this. I'm going to remove the screw, because on these screws I also like to put some 222 Loctite. As you can see, I've had Loctite there already on, so I'm just going to reapply it. I haven't had it a lot, but I've had on my other CNCs, if I don't put a little bit of Loctite on, or just a light gluing Loctite, over time they came off on me. I don't know why. Maybe it's the vibrations, especially if you start milling harder materials like aluminum, carbon fibers, things like that. There's a lot of vibration and forces, of course, working on the machine. And it seems like over time, these forces are loosening the screws. So that's why I like to put some Loctite on these. And like I said, the 222 is a brilliant Loctite, because I opened these screws the first time since assembly today. And Yeah, they were holding now, or easy, not holding, but easy to remove without a problem. Let's do the same on the front, and then this part is done. We don't need to touch it again. There we go. The new part is installed. If we now just quickly look at the old part again, this is what the old one looks like compared to the new one. So we can see this part here where the dust shoe is going to slide over is of course a little bit longer, and this part will now be set over there. So I don't know if we can see this on camera. We have holes here. So a M5 screw will be mounted on there, but we can only do that part once we install this onto the table. So I will guide you through once we mount this whole assembly back onto the table. The next part I would still like to do is install the end stop again. Now the idea, and I think I can show you a lot better how this is going to sit. Maybe we will have to remove this guy or slide it forward because it's just that extra too thick. So it's going to sit like that, and we're not routing the cable on the left-hand side or right-hand side if you stand in front of the CNC, but it's going to be routed in the front. It's going to come through there and then go into this extrusion. So that is the idea. If your cable is very hard, not very bendable, or not bendable at certain areas where you would like it to bend, my suggestion is just taking a heat gun on very, very low heat, just slightly heating up the outside insulation. That will help us to bend the cable into the desired position without having the risk of breaking the copper inside, because everything will be nice and soft. So that is what I'll do definitely, because I can feel there are some areas where I need a bend that it's not bending. But this guy will sit like this. I don't use Loctite on the end stops. I don't think it's necessary to put Loctite on these. But yeah, be my guest if you feel like you need to. And these again as well, just hand tight. You don't need to over tighten these. Right, this part here, this is the part that I meant that I would suggest heating up, because that part has to now bend in two directions. So I've set the heat gun to 100 degrees max. Like I said, we don't want to burn the plastic or the isolation of the cable. We just want to soften it. So, and also equally, we don't want to, of course, melt down the 3D printed part. We just want to make it nice and soft so that we can get around that bend that we need to. So important, keep on moving, don't stand still on one position of the cable, or you will start smelling and will go black and start smelling the plastic. Also, the good thing is these cables, they normally have higher melt rate than 100 degrees, so they shouldn't instantly go up in flames. And of course, if you don't have this isolation around, then it will be a lot easier to put your cables in. And number two is, worst case scenario, we just remove the isolation for that part and just bend around that corner. That would be worst case scenario, but also definitely possible. So I can feel the cable getting nice and warm. We don't want to just have the heat on the outside, also a little bit in the inside. It's also just to help the inside cables taking that bend nice and smoothly. There we go. That is what we are looking for. The end result, just click this guy back in here. So that is what the end result is supposed to look like. That this is nice and flat. And don't worry about it yet, about this guy, even if it pops out the front, because we still have to put the cover on for the dust, and this will keep this cable in place. Also, these little pieces, if you have the LDO kit, what the idea is, these guys here, let me just, these are two, like that. So these guys that you can put on the cable, we can of course put one over here as well. Actually, let's do that just for it not to pop out. Just cut off a small piece over here. And we can always remove it later on to put the longer piece then in that we need. So this guy is going to be like that. Let's just put it like that in position so it doesn't pop out again. So it can cool off in this current position that it is now. So that is all that we need. And just apply a drop of Loctite. Now these holes were designed with 3.4 millimeter clearance, so it shouldn't be a problem or any issues installing them into the holes. There's no need to pre-drill them. I took it off the print bed and I'm busy installing it now. Also something worthwhile mentioning. So I know some of the original Milo designs, which is nothing wrong with. I'll also do some designs like that, but this part here, I don't feel it needs to have super tolerances in the 3D print because it's actually just holding the dust cover for us. So yeah, I'm also just a little bit, it's hand tight plus, would say a quarter turn, just to make sure that these parts sit nice and snug. The carriage is also connected properly. That is all. I'm not putting on more tension because I don't want to crack and damage the 3D printed part. And did you know, maybe this is a fun fact while I'm busy doing this, I do not pre-test any of my 3D designs. This design is off CAD, 3D printed. I printed this once, except the TPU. That took me quite a few, it took me actually weeks to get that right. But the rest of the stuff is literally off the bed onto the object that I planned it for. So we'll see if it is a yay or nay at the end of the day, because I love experiencing it on camera with you, and I have no problem posting if it failed and we have to change it. But also the design factor behind it, what the ideas are, why I did it, and yeah, it seems to be working out for me so far. But I also had some bad luck where I had to really redesign things that didn't match or fit at all. Okay, so that part is now installed. So the whole idea behind this design is that you can remove this without removing everything. I hope you understand what I'm saying. So if we remove the front cover off here, so you will gonna have to remove your turning wheel like that. This guy's gonna come off. It's one screw. We've got 4 screws in here, and then you can actually pull this out and remove it, so you can now move the whole y-axis backwards, and you can get in there to do any maintenance, cleaning, lubrication, screwing, that whatever you need to do. Once you're done, you bring everything back forward again, you stretch it over into its position, And then you just literally put in your pins again, because they are not connected anywhere, they are just press fitted. So that's going to just sit in like that. So if you need to do maintenance work, it's going to be easy access, because you literally just have to remove the pin and pull the whole assembly out. So there's no, this is not a permanent fixture. The permanent part we assembled on these two parts. And then it's that everything doesn't fall apart like I showed in the beginning, or parts of the beginning of the video. This is now just going to mount on there. Also, you don't have to worry about clearance of this locking nut or mechanism in the front. That is just going to stay the way that it is. And these screws here are literally just going to be hand tight. There's no need to over tighten these screws. So inside this plate, you will see that in the documentation are blind or hidden magnets, 4 of them. And the magnets are there as well on the cover. At the top are also blind magnets, and they printed within the part. So when you're done, there we go. That is how it's going to look at the end. So your turning wheel is going to be flush to the front on that locking screw. We can now connect this guy again. I will have to reprint mine because one thread broke out. Just let's do that nice and hand tight. And then we put the dust cover. So this cover here, arrows, meaning you can only remove it upwards. You cannot move it left or right. And this is to protect this area here from dust. So it's going to sit on there like that. And that is what the end result is supposed to look like. So if we turn this, we can see the dust shoe, or the dust cover, that's not a shoe, is moving outwards. And if we open this, we can actually see what is going on. The cable is also not touching. And if we move it back again, we can see that it will move in, and we should hear a click, meaning the end stop engaged. So the end stop does get engaged, which is our goal. And that is the complete position. So, but it already triggered. So end stop, there it clicked. So with the cover on, that will be the end result, what your CNC is going to look like. So we have a cover on it, and it can travel the full distance. Your Y travel can travel from here, the full distance back. What do we lose? We lose 5 millimeters on the complete travel. Like I mentioned right in the beginning of the video, this TPU part, I had to make it thicker because of it would break if I would pull on it. And to make it more durable and lastable, I had to make it thicker, and therefore the travel loss is 5 millimeters. But I did check, you can still travel your 160 millimeter. It's actually more, it's over 160 millimeters, so you can still mill from bed edge to bed edge without a problem. If you had some bigger things that you were milling, of course that will not work like that anymore. But this is the end result that I was aiming for. So all the dust collects at the top, easy to vacuum, easy to get in here to clean, to make sure this is all nice and clean. There's no dirt in it. And yeah, that is what the end result is supposed to look like. Please consider subscribing or giving a thumbs up or hitting that notification bell, because there's more coming. This is only literally a little drop on a hot stone. We still have in the cable, there's something else to protect the lead screw at the back. This video is a lot longer than expected, but I think it was important, the information that I gave in this video, so that you guys don't have any problems installing this onto your Milo CNC. I am aware that Milo 2 is coming out. They have something similar to this to protect the rails and the lead screw. But I also know that there are more Milo 1.5s out at the moment on the market compared to our version 2, which is still in, I don't want to say beta, but decision making who's going to produce it for the Millennium team. And I think this is a very easy upgrade for your machine, and I can't wait to share it with you guys in the full build so that we can actually see what it's going to look, the end result is going to look like once it is installed. So yeah, I hope you enjoyed this, and I'll see you in the next video.